Okay, before we get into our practice with Snell's law today, I want to give you an actual demonstration of reflection and refraction. So what I have here is just a clear glass plate. Actually, a couple sides are clear. One side is cloudy or frosted over. Okay, this is exactly what we'd be using if we were in class and doing a lab with this. I'm going to put this on here, just a blank piece of paper. And I also have a laser. Very cheap, very small laser. There's a laser pointer. So what I'm going to do is I'm going to shine the laser. It's going to get emitted, and obviously it travels first through air, and then it's going to hit the glass. It's going to travel through glass. On the other side, it will re-emerge from the glass and travel through air again. So, and the key is, and it might not look like it from the video just because of the angle, I am not changing the angle that I'm trying as hard as I can not to change the angle that the laser shines in from. All I'm doing is moving the laser up and down a little bit so that it kind of spreads out along the paper. You'll see what I mean in a second. So if I turn this on and there we go. There we go. Okay, that's bright enough. So you can see if I kind of tilt this laser up and down a little bit, you can see very easily there's the incident ray going in towards the glass. Okay, again, all I'm doing is tilting this up and down a little bit so it spreads out along the paper. And that ray that you see, it's very faint, but coming out to the right of that, that is the reflected ray. Now, there is a ray that gets transmitted through the glass, and that comes out, if you look above the paper, on the other side. Okay, just because of the quirks of how I'm doing this, I can't get all three of them at once, or at least the angle's not right to show all of them at once. But if you look very, very carefully, and you see where the laser light enters, you can also kind of see where it exits the glass, and depending on how you look at this, okay, I just changed it a little bit, depending on how you're looking at this, you might be able to even see that it's very clear that the laser bends in the middle of the glass somehow. Okay, and what I mean by that is that it actually changes direction. The laser light that's coming out is not in a straight line from the laser itself. Okay, so that's an example of refraction. There's a refracted ray that's in the glass. You can't really see that one too well. But when it comes out of the glass, the fact that it is displaced from the original spot means that you know that refraction has occurred. I've got another little demonstration of this. Kind of cool. It involves a beaker filled with water. Okay, so here's our beaker filled with water. And if I shine the laser, you can't really see it in the water. You can kind of see it a little bit, but it's tough to tell. Actually, even right there, you can kind of see that it's not, like I said, it's not moving in the same direction. The reason it's curved right there is because the glass beaker is curved. So you can't really see the light ray or the laser in. Oh, there you could. Huh, I wonder why that is. Interesting. I've never seen that before. Maybe, oh, you know what it was? I think I was holding it up high enough so that it reflected downward. So you can't really see the laser under normal circumstances in the water, but you just take a little bit of milk, actually. You pour it in here. Of course, I just poured milk all over my counter. Okay, that's plenty. You stir it around a little bit. What we find is that now we can actually see the path of the laser because it hits all the little milk particles, and interestingly, you can actually see the bending of light as, I'm going to move this over a little bit, you can actually see the bending of light as the laser light passes through the milk. Okay, you can see where the beam of my laser, where the laser's pointing. You can also see that that beam is not quite, it's not going straight out from the laser once it hits the liquid. So that's pretty cool. Okay. Oh, there we go. That's a good picture. You can see it literally bending right through the liquid because it's a different index of refraction. Okay. So I guess what I'm going to do is actually stop this video right here. I'm going to clean this up real quick, and then we're going to go ahead and practice with Snell's law.